Hello again, I'm Chuck McLennan for Buick Know-How. Welcome to the Buick Know-How 1998 New Car Preview. We'll be looking at many product improvements that Buick implemented for the 1998 model year. So let's start by talking about the 1998 Buick Park Avenue. This car was an all-new model last year, so we'll treat 1998 as the year of refinement. The first refinement we'll cover is personal choice. Specific changes were made to the electrical system to accommodate an automatic parallel park assist feature, which is part of the memory seat and mirror package. The assist feature operates anytime the transaxle is in reverse. A motor is commanded to tilt the mirror down to provide the driver a better view of potential obstacles. If parking requires multiple shifts, a 5-second delay holds the mirror for parking. 5 seconds after shifting from reverse, the mirror tilts back up to its original position. Significant software changes were made to the driver door module, or DDM, to allow it to perform the parallel park assist feature. Parallel park assist can be toggled on or off using the DIC, which I'll get to in a few minutes. Another subtle change for 1998 is an enhanced version of the passenger window lockout feature. Again, this is another software upgrade that the DDM now handles. This year, 2 lockout settings are available: all passenger windows or only the rear passenger windows. Each driver's setting is remembered in the driver's key fob. Changing personal choice features is pretty simple. Just switch the ignition on and then press and hold the English metric button for 5 seconds. The DIC displays a Welcome to Buick option feature greeting. Once in the selection area, press the English metric button to move the pointer. Press Reset to save selections and to move to the next choice. Exit the menu anytime by pressing one of the remaining buttons. Buick upgraded the wheel speed sensors on every 98 Buick. Specific attention was paid to signal stability. That's very important for cars driven on rough pavement. Buicks through 97 use a toothed speed ring that rotates near a single pole magnetic pickup to generate an AC signal, which is sent to the EBCM. This sensor relies on a certain air gap between the teeth and the pickup. This critical air gap can be affected if the speed ring or the sensor cap is installed incorrectly. A loose wheel bearing can also change the air gap. If that happens, an inaccurate, erratic signal can be generated. Other potential areas of concern are chipped teeth and cracked rings. In these cases, the entire ABS speed sensor assembly would require replacement. The new sensor is a 47-pole continuous ring magnetic pickup that is molded into the cap. The hub-mounted toothed ring spins inside the cap. The stationary 47-pole continuous ring sensor counts each of the 47 speed ring teeth per revolution. The EBCM converts all 47 bits of wheel speed information and averages it to one value per wheel revolution. Using this averaging method, it is highly unlikely that a chipped tooth or a rough stretch of road would cause a signal loss. Now, let's spend a moment talking about OnStar, GM's newest division. As you may already know, OnStar provides travel directions in addition to many other customer convenience features. In this know-how, we're going to talk a bit about how the system works and explain a few of the features. One of the most powerful and successful features is the personal contact between an OnStar advisor and the customer. While advisors converse with customers, 3 global positioning satellites locate the customer's Buick anywhere in the continental United States. Some of the basic features include route directions, airbag deployment detection, 911 emergency services, roadside assistance, remote light flashing, remote door unlocking, and stolen vehicle tracking. Every 98 Buick is factory built for OnStar, although the system is dealer installed. However, the dealership and the dealership technician must be certified by OnStar before the system can be sold, installed, or serviced. OnStar hardware includes a receiver with a wiring package, a satellite receptor, and an OnStar cellular telephone. In addition, an up-level Gen 3 radio is required. Only up-level radios have 32-bit memory that's capable of handling the radio's amplifier, speakers, and muting demands on the system. OnStar also has a sleep mode to conserve battery power. This feature begins operating 1 minute after the vehicle has been turned off. The system sleeps for 9 minutes, then wakes up for 1 minute. During this wake-up interval, the system checks for incoming OnStar Center calls. After 48 hours, the system shuts down completely. No vehicle integration services can be performed. The only help that the OnStar Center can provide the driver is roadside assistance or a locksmith. Keep this in mind if you are diagnosing the system and nothing seems to be working. Once the car is unlocked by the driver, the entire OnStar system comes back online. Now, let's talk about the new Onboard Refueling Vapor Recovery System, or ORVR, that's on all 1998 Buicks except LeSabre. The system significantly reduces vapors released during refueling. We'll take a look at all of the new Evap system components, starting with the Evap purge valve. The purge valve is right up front, close to where it was placed last year. A bright green service port has been made available for connection with the Evap test equipment. All ORVR systems are sealed, so the new quarter-turn gas cap acts both as a pressure seal and a vacuum vent. Look inside the fuel filler neck. Notice that the nozzle opening is smaller. This provides a seal between the opening and the nozzle to seal vapors. This tight fit may concern some customers, so be prepared to explain the new design. When the tank is being filled and the nozzle shuts off, fuel occasionally spills out of the filler neck. An in-tank check valve at the bottom of the fuel fill neck limits spitback. An in-tank shutoff valve assembly determines fill level, prevents fuel from being forced into the canister, and provides rollover fuel spillage protection. The fuel tank pressure sensor is very similar to a MAP sensor. The PCM reads ambient pressure here and tank pressure here. The PCM uses a 5-volt reference signal to sense fuel tank pressure. Monitor the voltage with a Tech 2. Normal voltage is 1.3 to 1.7 volts. These readings can be obtained by removing the fuel cap. The fuel vapor lines transport fuel vapor from the tank to the Evap canister. It receives and stores fuel vapor from the fuel system. The normally closed Evap vent valve is near the Evap canister, controlled by the PCM. When the vent valve is opened, outside air enters the canister and pushes vapors from the canister to the engine. Now that we're familiar with the components, let's talk about how the system creates and maintains a vacuum in the system to diagnose itself. Several new codes relate to the Evap system. Even something like a loose fuel cap can set a code. Up to 6 different OVRV system DTCs can be set. Let's look at DTC P0440 to see what sets this code. The PCM opens the Evap purge valve, allowing a slight vacuum to be drawn on the Evap system. After closing the valve, the PCM monitors fuel tank pressure for any changes in vacuum. A vacuum leak sets code DTC P0440. Look for a disconnected or malfunctioning fuel tank pressure sensor, a missing or malfunctioning fuel cap, a cracked, punctured, or malfunctioning Evap canister, a damaged or disconnected source vacuum line, Evap purge line, vent hose or fuel tank vapor line, a poor PCM connection, backed out, improperly mated, formed, or damaged terminals, poor terminal to wire connections, damaged wiring harnesses to the Evap vent valve and purge valve, or evidence of a problem with the carbon canister. The Know-How Reference Manual has more detail on all of the new OVRV codes. Now let's move on to the front suspension area. Buick made considerable improvements in the Park Avenue and Riviera front suspension. Some 95 to 97 Rivieras and 97 Park Avenues may have a vibration known as high-speed shake. These cars may have this concern primarily because the structure is so stiff, and that means that the car is very sensitive to road input, so it doesn't take much tire imbalance to produce the concern. Some 95 to 97 Rivieras and 97 Park Avenues with high-speed shake had to have new tires installed. The tires were hand-selected from those measuring little or no vibration on a 70-mile-per-hour test machine. The best tires were sent to the dealership to be mounted on the car. This program has decreased because these 98 production tires are nearly as good as last year's hand-selected tires. Remember, replace tires with the exact brand, size, and tire performance criteria number to assure correct performance. If a car has a high-speed shake concern, check the wheels for bends, nicks, or other damage. Be sure to check for proper inflation pressure. Another very important check is lateral and radial runout of the wheels and tires. To perform these checks, attach a dial indicator to the car. Position the indicator on the bead area of the rim for a side-to-side reading. Rotate the gauge faceplate to 0. Now, turn the wheel one rotation. This reading indicates lateral runout of 0.08 of an inch. The specification is 0.30 of an inch. Now, move the dial indicator tip to the tire bead area to see if the rim is round. Again, zero the gauge faceplate. Turn the wheel once. This reading is 0.06 of an inch. To check the tire for lateral runout, position the dial indicator against the tire sidewall. Zero the gauge. This reading indicates a tire lateral runout of 0.10. After taping the center line of the tire, set the dial indicator tip on the tape. Tire radial runout tells you if the tire is round. The tire radial runout is 0.14 of an inch. If everything is in spec, balance the tire. First, mark the rim to stud as well as tire to wheel orientation. This ensures that everything gets remounted in the same relative position. Perform an off-car two-plane computer balance. If you have one, an on-car wheel balancing spinner can be used to wheel balance one wheel at a time. Remember, balance the tire again if it's rotated to another axle, if the wheel is remounted on a different stud, or the tire is rotated on the rim. Finally, tell the customer that a finished balance may cure high-speed shake and that the tire may require rebalancing whenever it's remounted. To minimize the high-speed shake concern, Buick had to reduce the sensitivity of the car. Buick accomplished this with a new front lower control arm. The front bushing was turned to the horizontal axis, contrary to the previous vertical orientation. The new horizontal front bushing is a hydraulic design, meaning that hydraulic fluid inside the mount provides a high rate of damping. The rear bushing is a two-piece design. Buick found that two bushings provide less fore and aft control arm movement than one larger bushing. The ball joint, rear bushing assembly, and front bushing form a triangle. Road input from the ball joint pushes rearward. The rear bushing acts as a pivot point, forcing the front of the control arm to move. The in and out movement is controlled by the fluid flow within the hydraulic bushing. Another suspension enhancement is a new front strut top mount. The new mount reduces lumbar noise while also providing a softer suspension feel for Riviera and Park Avenue. A new mount utilizes a shear design. Rubber is bonded to the outer and inner sleeves. The outer sleeve is held by the mount plate. The inner sleeve holds the strut rod. As the strut rod moves up and down, the inner sleeve deflects the rubber. In addition, the mount has been specially tuned to eliminate lumbar noise on rough roads. Suspension movements cause the mount to vibrate. When these vibrations match the frequency of the mount, a rhythmic droning noise is created. Grooves and slots are molded in the rubber to change the natural frequency of the mount to prevent lumbar noise. Oh, and another thing, front alignment specifications have been changed for 1998. Toe and negative camber have been increased to help improve tire wear and vehicle handling. These changes are specified in the know-how manual. How about this for a new 98 feature? Regal LS and GS and Century Limited and Custom now have an optional power sunroof. Let's cover some of the items you may need to look for with this new option. Drain tubes duct water away from the sunroof module. The front drain tubes connect to the sunroof module and are routed down the A-pillars and out through an opening between the front door hinges. The rear drain tubes are routed down the C-pillars and out through an opening at the bottom of the car. If the concern is a water leak or a wind noise, start by making sure the sunroof is completely closed. The glass may require an adjustment to effectively seal against water and wind. These concerns may indicate misaligned glass or possibly a damaged weather strip. Loosen the screws to adjust each corner of the sunroof. The front of the glass should be 1 millimeter below the roof surface. The rear should be 1 millimeter above the roof surface. Once the glass is correctly positioned, tighten the screws to 4 Newton meters or 35 pound-inches. Water leaks may be caused by plugged, frozen, pinched, or disconnected drain tubes. Another new feature for the 98 Regal LS, GS, and Century Limited is a 6 or 12 disc CD changer. These are extra cost dealer installed options. Keep in mind that the car must have manual or automatic dual zone climate control. Then check the radio. If it's a base radio, it must be removed and upgraded. An up-level radio with cassette or CD player and cassette must be installed. These radios have the 32-bit memory to operate the CD changer. Install the changer in the trunk area. The CD changer connects to this factory-installed harness. This CD changer harness can be installed by the dealer if the CD changer was not factory ordered. The 3100 V6 engine and the supercharged 3800 V6 engine are both equipped with an overheat protection feature. The PCM has a new software mode for 1998 that monitors engine coolant temperature. Overheat protection mode kicks in when engine coolant temperature exceeds 124 degrees centigrade or 255 degrees Fahrenheit. When the engine coolant temperature drops below 121 degrees centigrade or 250 degrees Fahrenheit, the engine operates normally. Engine ignition timing is set to a fixed position. 3 fuel injectors are disabled for 10 seconds. Those injectors left operating run with a richer fuel mixture to promote engine cooling. The software alternates injector operation every 10 seconds. Obviously, the engine won't run like it should, and customers will be concerned about the reduction in power. Technicians may even misdiagnose this as a drivability concern. Reassure them that their Buick is operating properly. Thank you for watching Buick Know-How's 1998 New Car Preview. The product enhancements pointed out in this program should help you understand the subtle engineering changes that were made for 1998. And, as always, take a good look at your know-how manual for all of the 1998 details. See you next month.